Here I want to take you through really quickly about two things. This was originally supposed to be two videos: solution dilution and solution reactions, solution and chemical reactions. The first part is solution dilution. What happens when you dilute a solution? All right. Well, if you think about the analogy of those cans of orange and apple juice you can buy from the grocery store in the frozen section, and they tell you to mix with water. It's like 1 can of concentrate and 3 cans of water. Well, what you're doing is making a dilution there. But can you understand that the amount of orange that you have is always going to be the same no matter how much you dilute? So the analogy is the number of moles that you have, moles of whatever, is going to be the same whether it's in 1 milliliter or if you expand it to 1 liter. If you had, say, 5 grams or something, it's going to be 5 grams whether it's in here or whether it's in here. It's just if it's in here, it'll be more spread around. The point is, moles of something, in this case moles of sodium nitrate, is going to be the same if you have a certain amount of it, whether you have 75 mils or 600 mils. All right. So the question here is talking about dilution. It says, what's the molarity of a solution prepared when 75 mils of a 10 molar solution of sodium nitrate is diluted to 600 mils? So the key word here is diluted. The volume is added. Right? Now, you would imagine that if your volume goes up, your concentration is going to go down. That's exactly what happens when you add water with your orange concentrate. All right? And that is expressed by this equation here. This is the dilution equation. M1V1 is M2V2. Molarity 1 times volume 1 equals molarity 2 times volume 2. All right? What that essentially means is the number of moles to begin with is equal to the number of moles at the end, except you're changing your volume and molarity. All right? So in order for us to answer this question, we have to know several things. And first of all, actually, we don't need to know the formula for sodium nitrate. All we need is to know is which of these 4 variables we're looking for. So let's read the question. It says we've got 75 mils of a 10 molar solution. These are our initial numbers. This is our initial volume. This is our initial molarity. This is our new volume. Notice we don't have a new molarity. That's what we're trying to find. Now, if you remember, molarity is expressed in the units of moles per liter. So what do we need to do to this number of mils and this number of mils? Well, it's exactly the same thing. We've got to make sure they're in liters. So 75 mils is 0.075 liters, and 600 mils is 0.6 liters. All right. Now, if we're looking for M2 here, how would we rearrange this equation to get M2 by itself? Well, of course, M2 is going to be M1V1. So that should be a V. What the hell was that? M1V1 divided by V2. These are the 3 variables we know, so we're going to plug them in. M1 is 10. V1 is 0.075, and V2 is 0.6. Now, if you were to think about it, the units of the 2 volumes are liters. They will cancel out. The units of our concentration was moles per liter, so that's what you'll be left with. And when you do the math, what you get is a concentration of 1.25 moles per liter, or 1.25 big M. All right? Either one of these units is fine. 1.25. Now, just think about that for a minute. If your volume goes way up here, almost by a factor of 10, which means your concentration is going to go down by the same factor. All right? This actually went up by a factor of about 8. So it means this should go down by a factor of 8. If your volume went up, your concentration is going to go down. So your concentration was 10. If the answer is right, the concentration should be lower, and it is. So it's always a case of looking at M1V1 as M2V2 and figuring out which of the 3 variables you need to calculate. Now, this formula only works when you're doing a dilution. All right? If your question is not talking about dilution, this question doesn't talk about dilution, we aren't going to use that. And in fact, this one's asking about grams. How many grams of potassium carbonate are needed to make 750 mils of a 3 molar solution? All right. Well, whenever a question gives you something in molar and it gives you a volume, and knowing that molarity is moles per liter, you're probably going to have to do something to this number of mils, and it's what we did on the last question. So we'll just convert it to liters, 0.75 liters. But it's asking for grams. Now, you know that, well, first of all, potassium carbonate is this. And if you're asking for grams of that, the only way to get there is if you had moles of that. We use our molecular weight to get from here to here. But we need to use this information here to get us to moles. So let's start with one of these. Let's start with the 0.75 liters. All right, 0.75 liters. We're trying to find moles here. We know molarity is moles per liter, so therefore 3 moles per liter. Of course, our liters cancel out, giving us, that's going to be 2.25 moles of potassium carbonate. All right, but we don't want moles, we want grams. All right, so that's what we're going to find. At least that's what we're going to try and find. Okay, so for potassium carbonate, if we have our 2.25 moles, 2.25 moles of potassium carbonate, we've seen this before. To get to grams, we know if we have 1 mole, we have whatever the molar mass is in grams, and that turns out to be 117.98 grams, something like that. And then 2.25 times 117.98, and crap, I don't know where my calculator is. Oh boy. So I was getting myself ready, getting this video all prepared, and my 3-year-old son was messing about with my calculator. I don't know, he's probably shoved it up his butt or something. Anyway, I don't know where my calculator is. So 2.25 times 117.98 is going to give you whatever the answer gives you. And the answer is going to be in grams, all right? As you would expect, all right? Now, let's do another question. What if we have a... oh, dude, what happened there? Hang on a minute. What happened? Okay. What if we have a question like this? We have a reaction between zinc and HCl, forming zinc chloride and hydrogen. Whenever you have a question like this, the first thing you always want to do is make sure, is the equation balanced? All right? 1 zinc, 1 chlorine, 2 oh, wait, that's not balanced, is it? 2 hydrogens, 1 hydrogen. Oh, you know what? I can balance it with that. Okay? So, when the question asks you something like this, it says, how many grams of zinc, it's asking for grams of zinc, can react with 225 mils of 0.2 molar HCl. Now, in previous questions we've seen, it could have been something like, how many grams of zinc can react with, say, 25 grams of HCl? And you take the grams and convert it into moles, and then get to moles of zinc and grams of zinc. Well, this is exactly the same thing, except you aren't given grams of something else, but you do have a volume and a molarity, so you can figure out moles from that. Except, of course, we have a volume in milliliters, so we've got to convert it into liters. 0.225 liters. All right, so let's start with that. We have 0.225 liters of our HCl. We're trying to find moles, and we're going to use the volume and multiply it by the molarity. So we know we have 0.200. Why does it keep doing that? That's annoying. Moles per liter. And so this gives us 0.45. No, bollocks, it doesn't give us that, does it? Hang on. No, it doesn't give us bollocks. No, it gives us just an answer that I messed up. Now, I worked all this out before, and so that should be 0.045 moles of HCl. All right. Now, we don't want moles of HCl. We ultimately want grams of zinc, and the only way we can get grams of zinc is if we had before moles of zinc. Right. So if we have our 0.045 moles of HCl. And we know that for every 2 moles of HCl, I need 1 mole of zinc. Now can you see where I'm getting these numbers from, the 1 and the 2? Oh yeah, they're just from the balanced equation up here. That will tell me then that I have 0.0225 moles of zinc. All right. But again, I don't want moles of zinc. I want grams of zinc, and 1 mole of zinc weighs 65.39 grams of 1 mole. So therefore 0.0225 moles of zinc times 65.39 gives 14.7 grams of zinc. So these are just stoichiometry problems, except you're getting moles from a volume and a molarity rather than from a number of grams that you've seen before. All right. So a similar sort of question. Sodium sulfate, aqueous, and barium chloride, aqueous, react together to form barium sulfate, which is a solid, and 2 moles of NaCl. Now this equation actually is balanced, and you can check it just to be sure, but it is. It says how many milliliters, so it's asking you for volume, how many milliliters of 0.330 molar sodium sulfate I needed to react with 26.8 mils of 0.216 molar solution of barium chloride. So it's given you a volume and a molarity, and a volume of molarity and a volume. However, this does not mean that you're going to use this. This equation is only for dilutions. This is clearly not a dilution, this is a chemical reaction. And the reason why you aren't going to use this is because a reaction like this doesn't take into account any mole ratios here that are not 1:1. It turns out that this one is 1:1, but if it wasn't, if I asked you for, say, barium sulfate and NaCl, using this you wouldn't be able to take this coefficient into account. So the way to get around that is to not use this at all if you're not doing a dilution equation. The way to go about this is, if we have a molarity and we need a volume, and we know the molarity and the volume of the other species, we know we can get moles from volume and molarity. So if we use the volume and the molarity of BaCl2, we can get moles of BaCl2. If we know moles of BaCl2, we can get moles of sodium sulfate from the balanced equation. If we then know the moles and the molarity, we can get to the volume, which is what we're going to try and do. Except we've got to do the thing we always do with our volume and convert this into liters, so 0.0268 liters. So what we're going to do is take the information for the barium chloride that we have and figure out how many moles of that we have. So we've got 0.0268 liters of barium chloride times 0.216 moles per liter, also of barium chloride. And that gives us 5.789. God, this pen is doing some weird things. Times 10 to the negative 3 moles of barium chloride. Now, when you look at the balanced equation, you'll see that you have a 1:1 ratio here. So in this case, we have the same number of moles of sodium sulfate. So therefore, we have, I'm not going to show you the 1:1 conversion factor. So this number of moles of sodium sulfate. Now, the only other piece of information we have is the molarity. And we know molarity is shown in units of moles per liter. But we need units, well, first we need units of liters, and we'll get to milliliters from that. If we need units of liters, can you see if we write moles per liter on the top, moles on the top, liters on the bottom, our units won't cancel. So we've got to put liters on the top, moles on the bottom. We just got to remember that molarity means 0.330 moles per liter. So that gives us 0.0175 liters of our sodium sulfate. And then if you know your conversions, to go from liters to milliliters, we multiply by 1,000, so that means 17.5 milliliters of sodium sulfate. So that's it. That's dilution and using solutions in chemical equations, chemical reactions. It's really not that tough. All right, thank you.